We are STEM scholars, and we're here to teach you about the world.
Hi, I'm Tyler.
Hi, I'm Aaron.
And I'm Dylan.
And we're here to tell you why hand washing is so important.
Germs is a general term to describe bacteria. Bacteria are tiny organisms that live everywhere on the surface and within our planet. Bacterial cells are present everywhere on the earth, including on and inside of the human body. There's a small percentage of bacterial cells that are bad for the human body, and they are known as pathogens. These bacterial cells, when entering into the human body, can cause damage to the host, which would be you, if they were inside of you. Pathogens can make you sick. You can get pathogens on your hands by touching objects that you encounter throughout your everyday life, such as a light switch, a door handle, or even shaking somebody's hand. Once these pathogens get on your hands and you go to eat food without washing your hands, you can transfer the pathogens into your body, which would likely result in you getting an illness. What we have simple blue paint that has been applied to my hands. What I'm going to do is I'm going to wash my hands off with just water and show you how it doesn't take off all of the blue paint. And then I'm going to use soap to get off the rest of it.
These hands were washed with only water, and you can see that the blue paint is still there. And these hands were washed with soap and water, and all the blue paint came off. So it's much better to wash your hands with soap and water.
To illustrate this, we just took some motor oil and combined it with water and stuck it in a 2-liter. You can see here how the oil separates from the water pretty distinguishably. And when you shake it up, it will again go back to those same separated layers. So now it's obvious why you shouldn't just use water if you're looking to remove things that might be more oily. The separation between this oil and water arises from a chemical property known as polarity. Basically what that means is the oil is much less polar, so the oil is going to stay with more oil molecules. The water is much more polar, so the water is going to want to stay with more water molecules. So the same polar properties that I just talked about with the oil and the water are both found in all the soap molecules. That is, there's a polar head in the soap molecule and a nonpolar tail.
Let's look at the chemistry of soap. Soap actually has the polar properties of water and the nonpolar properties of oil in each molecule. So imagine if we have a bunch of these soap molecules in a solution where the water is drawn in blue and these red squigglies represent whatever dirt, oil, or bacteria it is you're trying to remove. So if we allow these things to mix, you can see that the nonpolar tails align with one another and the polar heads attach to one another along with the water.
To the water and oil mixture, we have added soap. And when you mix it around, you can notice how the oil does not separate out back from the water instantly. And there's definitely not a defined line like there is with just a water and oil mixture.
Now you know the science behind why you should wash your hands to remove possible pathogens so you don't get sick.